Hey guys, it's Ankush, and today I'll be introducing you guys to the addition of halogens. First I want to start off by saying the solvents are either CCl4 or CH2Cl2. The first step of the reaction is an electrophilic attack to form the halonium ion. In this case, the alkene acts as a nucleophile and the halogen acts as the electrophile. The double bond attacks the halogen, which causes the electrons in the bond to go on to the other halogen. This forms the halonium ion and then also the halide ion. In step 2, the halide ion opens the halonium ion. The halide ion acts as the nucleophile and performs a back attack on the carbon, which causes the carbon-halogen bond here, the electrons in it, I should say, to move up onto the halide. A result of this is an anti-addition of two halogens. Now, because it is an anti-addition, both enantiomers will form from this reaction, as we can see here. Not only will this enantiomer form, but also the other one will. Now, let's talk about the pros and cons of this reaction. One of the pros is that it can be used in the bromine test with CCl4. CCl4 is a dark red-brown color. When we do this test, if the color disappears, that means an alkene was present. The Br2 reacted with the alkene. If the brown remains, there was no reaction, which tells us there was no alkene present in the molecule tested. The cons are that this reaction will yield both the enantiomers, so it's difficult to get one over the other.
Hey, it's Logan, and I will be talking about the formation of halohydrons. And now in this mechanism, the first step is the electrophilic attack that forms a halonium ion. In this reaction, your alkene will act as a nucleophile, and your halogen will be an electrophile. And as you can see, the nucleophile attacks the electrophile, and this causes the electrons that is formed between these two halogens to now move to one halogen. And you can see your products is now the halonium ion as well as a halide. Now, in your second step, water opens the halonium ion, which is a nucleophilic attack. And in this, H2O acts as a nucleophile, and you can see it does a back attack on this carbon, which moves these electrons between the halogen and the carbon to now move only to the halogen. And your products in this is now the carbon with a halogen on it, as well as a carbon with water on it. Now step 3 is the deprotonation. And in this one, water will now attack the other water molecule that's connected on the carbon, and it will take this hydrogen and move the electrons between these two to this oxygen. And in this, you get 3 products, but the main product we're looking for is now your carbon with the halogen and now your carbon with an alcohol on it, as well as your hydronium and then your halide. Now, an important thing to remember is the attack of the H2O occurs on the more substituted carbon to get a Markov-Nikov product. Now, the pros of this reaction is that water is accessible everywhere. So with the huge excess of water, it makes a great solvent. But the funny thing is the con, the only solvent you can use is water, or else you get a completely different reaction.
Alright guys, so now this is going to be our question here. We have 4-methyl-pent-2-ene reacting with Br2 and carbon tetrachloride. Now, pause here, and then we'll come back and see what the answers are. Hey guys, welcome back. So the answers to this will be the 2 different enantiomers that go along with an anti-addition of 2 bromines. So, first we have this one. We'll have 1 bromine here, 1 bromine. One bromine here. Now the enantiomer of this will have the opposite stereochemistry.
Hello, this is my question. Why does the H2O attack the more substituted carbon in the formation of a halohydron? You can think about the answer. I'm gonna write it down and then I'll talk about it after. Alright, so the answer to this question is, the more substituted carbon in a polonium ion has a more positive charge. So this means that the electrons on the oxygen in H2O will attack that carbon, which will in turn give a Markov-Markov product. Thank you.